That's because they don't attach to holes through the circuit board. Instead, they attach to lands on the surface of the board with either special leads or leadless terminations. We'll talk about leaded components first. Surface mount components typically have 4 styles of leads: gull wings, J leads, L leads, and I leads. Gull wings and J leads are the most common. The gull wing lead is a metal lead that bends down and away, similar to a seagull's wing. Some gull wing components are said to have fine pitch. Pitch is the distance between the center of one lead to the center of the next. Fine pitch means that the leads are spaced very close together. J leads have metal leads that bend down and underneath the component in the shape of the letter J. L leads are usually found on molded tantalum capacitors and on some chip inductors. L leads are inward formed, almost touching the body of the component. I leads are actually through-hole leads that have been cut short for surface mounting. The end of the modified lead is placed directly on the surface mount land. As you can imagine, this connection won't be as strong or stable as the other types of surface mount leads, and IPC standards do not permit their use on high reliability products. Next, let's take a look at the leadless types of surface mount connections. Leadless means there are no metal leads sticking out of the component body. Instead, the components are attached to the circuit board by soldering to some type of metallized termination on the component. The most common type of metallized termination component is the chip component, with 3 or 5-sided terminations at opposite ends of the component's body. Castellations are another form of leadless connection. These half-round metallized recesses in the side of the component are filled with solder when connected to the circuit board land. The last type of leadless connection is the ball grid array, or BGA. BGAs consist of rows and rows of tiny balls of solder on the bottom of the component. These solder balls are connected to matching rows of lands on the circuit board. Let's stop and review the material we just covered. In this section, we'll be examining the surface mount ICs. We'll start with the large-scale ICs. The larger scale ICs usually come from the manufacturer in waffle trays. These complex components may be packaged in several package styles. The 2 most popular of these styles are quad flat packs, or QFPs, and plastic leaded chip carriers, or PLCCs. We'll talk about QFPs first. The body of a QFP is usually plastic. Sometimes the bodies are ceramic or metal. QFPs have gull wing leads on all 4 sides. There are anywhere from a few to hundreds of these leads. The body of the component is usually marked with a part number, date code, place of manufacture, and the logo of the manufacturer. The reference designator for QFPs, like all other surface mount and through-hole ICs, is also indicated by the letter U. Orientation for QFPs is indicated by a dot or a beveled edge over the number 1 lead. Sometimes there may be a chamfered corner or a stripe for pin 1 orientation. Now let's look at PLCCs. PLCCs are also a popular large-scale IC package style. They have up to 100 J leads on each of the 4 sides. Notice that J leads are not spaced as closely together as the gull wing leads on fine-pitch QFPs. Orientation markings for PLCCs are not the same as for QFPs. A center dot indicates pin 1. Next, let's discuss the 2 types of leadless large-scale surface mount ICs: leadless chip carriers, or LCCs, and ball grid arrays, or BGAs. LCCs are most commonly used in aerospace applications because they are extremely rugged. Smaller, hybrid varieties are currently being designed and used for other electronics applications. As we mentioned earlier, LCCs utilize half-round metallized recesses in the side of the component called castellations. There can be up to 124 castellations on the larger LCCs. Like the leads on ICs, castellations are counted counterclockwise from the pin 1 orientation mark. The other large-scale leadless IC is the BGA. Instead of leads, the BGA contains from 25 to 625 or more tiny solder balls on the bottom of the component. These solder balls connect to a matching set of lands on the circuit board. The body of the BGA may be made of plastic, ceramic, or metal. BGAs utilize the same orientation markings as the other large-scale ICs. At this point, let's take a look at the smaller scale ICs. These smaller packages with leads on two sides are called Small Outline Integrated Circuits, or SOICs. SOICs are the surface mount equivalents of through-hole dips. These components come from the manufacturer in tubes or on tape and reel. SOIC bodies are most commonly plastic and have gull-wing leads. When they are provided with J leads, they are referred to as SOL-J. Like the larger scale surface mount ICs, orientation is indicated by a dot or beveled edge over the number 1 lead, or by an end notch or stripe on the body of the component. Other styles of SOICs are all gull-wing leaded components that usually begin with the letters SO for small outline. The remaining letters refer to the size of the component package or to the thickness of the body, where T refers to thin packages. Let's stop again and review the material we just covered. In this last section, we'll be discussing chip components, MELFs, transistors, and diodes. We'll start with chip components. Chip components usually have ceramic bodies with metallized terminations on either end. The most common types are chip resistors and chip capacitors. Inductors have recently been introduced in this style package. These components are usually very small and come from the manufacturer on tape and reel. Chip components are typically placed on a circuit board using high-speed chip shooters. Because the components are so small, there's often no identification marking on the body. This makes reading the value of the component impossible. That's why it's critical that the part number on the reel is verified against the bill of materials, and that the feeder containing the reel of components is loaded into the correct feeder location on the chip shooter. Like their through-hole counterparts, chip resistors use the letter R as a reference designator, and chip capacitors use the letter C. Chip resistors and capacitors may have numerical value and tolerance codes rather than color codes. These codes are sometimes printed on the component body if the component is large enough. More often, the value and tolerance is printed on the label of the tape reel along with the part number. The Component Identification Desk Reference Manual contains an explanation of how to read the number codes for resistors and capacitors. Another type of chip capacitor is the molded tantalum capacitor. This type of capacitor has inward-formed L leads that look like metallized terminations. Molded tantalum capacitors are polarized. Polarity is indicated on the positive or anode end by a plus sign, a line, or the letter A. The top of the component may also be beveled on the anode end. The physical size of the molded tantalum capacitor is described by one of four letters: A, B, C, or D. A is the smallest and D is the largest. Next, let's examine MELFs. MELF stands for Metal Electrode Face and is a type of package. MELFs have metallized terminations on each end of a cylindrical body. MELF components include resistors, capacitors, diodes, and inductors. Like chip components, MELFs usually come from the manufacturer on tape and reel. The label on the reel will usually display the part number. Reference designators and value coding are pretty much the same for MELFs as for their surface mount chip and through-hole counterparts. For example, the color band system for specifying value and tolerance on MELF resistors, capacitors, and inductors is the same system that we use for through-hole components. MELF diodes have a band on the negative or cathode end to indicate polarity. The last surface mount package styles we'll discuss are small and large transistors and diodes. Small outline transistors, or SOTs, are small rectangular transistor or diode packages. SOTs usually have 3 or 4 gull-wing leads on 2 sides of the package. SOTs come in different sizes. The most popular SOT is the SOT23. As with any transistor or diode, the reference designator is Q for transistors and D or CR for diodes. Orientation of SOTs is determined by the lead and land patterns. There is only one way to place the component. Diode packages, or D-packs, accommodate more complex groups of large transistors or diodes. D-packs have 2 or 3 gull-wing leads on one side and a heat sink on the opposite side. Like SOTs, they can only be placed on the board in one orientation. Both SOTs and D-packs have equivalent through-hole transistors and diodes. This program has presented many of the most important details of component identification. In Part 1, you were introduced to through-hole components and took a look at the relationship between the component, the circuit board, the assembly drawing, and bill of materials. We also discussed component values and tolerances, polarity, and orientation. Part 1 continued with the identification of through-hole components. We covered ICs, common axial and radial components, and the remaining types of through-hole components and connecting hardware. Part 2 began with a discussion of the differences between through-hole and surface mount components. Then we identified the surface mount components. First, we looked at the larger scale leaded and leadless ICs. Next, we examined the small outline ICs. And we concluded with a discussion of chip components, MELFs, SOTs, and D-packs. Identifying components correctly is one of the most critical jobs in electronics assembly. Improper component ID can result in damage to the component and circuit board. It's important to understand part numbers and reference designators, as well as component values and tolerances. And you need to be able to verify polarity and pin 1 orientation. Careful attention to detail will help to make sure that your company's products work properly and reliably.